Hello there everyone, welcome to Ferrum Forge Knife Works. This is Chris here, and today we're going to do another video about anodizing, my favorite topic. So we've been through the effect of different surface finishes on anodizing. We've gone through different chemical pre-treatments and the effects that it has on anodizing. So today we're going to look at another variable, and that is the electrolyte solution that we anodize in. So we're going to do some experimenting. We've got distilled water, which we should theoretically see no effect with. We're going to go with our beautiful San Diego City tap water, which has got some goodies in here. This one, I don't know if you can see it, this is ocean water from the Pacific. We got that the other day. This should, it's full of salt and all sorts of other things. This should have an effect. We got our handy dandy sports drink. It's got electrolytes, very good. And I'm gonna do a dish soap solution to see, I don't know what's gonna happen with that one. And we're gonna do some beer, some nice light watery beer. Don't wanna use the good stuff on that. So we're gonna check it out and see what happens. Quick note about electrolytes before we go too much deeper into this. Of what an electrolyte is, and it is very, very simple. It's anything that's dissolved in solution that conducts electricity. So, for example, like salt water. Salt dissolved in water will conduct electricity. Water, any water that has a mineral content will theoretically conduct some electricity. So we're going to look at different electrolytes and different solutions and see what happens. All right, first things first, we're gonna do a piece in my standard solution just to show this is gonna be what we're comparing everything else against. So we're gonna do everything at 33 volts, which should get us a nice blue color. Everything's run down. All right, so this will be our comparison piece. Now that we have our comparative piece that was done in the standard anode tank, now we're going to start testing our other solutions. And to do that, we're going to put everything into one of these containers, and this titanium piece, this 6/4 tie, this is going to be my cathode to keep everything as consistent as possible. So right now, this is the tap water in this bowl, and let's see what happens. Here we are with our setup. We have our negative attached to the cathode, and I have my positive attached to the workpiece. Everything's set at 33. Let's see what happens. So not much is happening, but you can see we're getting bubbles. We have bubbles forming on the cathode, and we have bubbles here on our anode or the workpiece. So there is a reaction occurring. Something is happening in there. You can see on the power supply, we kind of keep wiggling between 0 and 1. So we are having an effect. Just not a very strong or powerful reaction in the tap water. Let's see. So this is our tap water piece. It's got a very light bronze coloring to it. So the tap water, not very effective. Has an effect, but not very much. So that's our 33 volts with my standard rust remover. It's a nice pretty blue. And then there's the tap water. Not so awesome. Now let's check out the ocean water. See how this does. Right, here we go. Anodizing with ocean water. Well, that is a very violent reaction going on here. Wow. Fascinating. It's a lovely smell that you guys can't get. So you can see my amps are really ramping up, so there's a lot more resistivity going on. Huh. Interesting, fascinating. I have no idea with this one. So here we have the piece that was anodized in the salt ocean water. You saw it had a very, very violent reaction. I don't know exactly what's going on, but here, focus for me. You can see that I got a bunch of weird pitting. We got some strange discoloration around the edges and around the hole there. Some bronzy color, but definitely not pushing up to blue. You know what, let's take a look at the actual salt water itself. How I went from there to brown and disgusting. I don't know. I really don't know what was going on with this one. Maybe needs a little bit more research. Let's do some sports drink. It's got electrolytes. There we go, 33, everything's in. Oh, it's bubbling. See at the cathode, we're bubbling. So that means electrons are being transferred. The chemical reaction is taking place at the cathode and the anode. The cathode releases the electrons, the anode consumes the electrons. This one smells much better. Not a tremendous effect. Let's leave it in and see what happens. You can see in there is definitely a reaction occurring. The Gatorade, Brondo, it works. This smells a lot better than the ocean water, let me tell you guys. Well, let's clean it up and check it out. Now that I've anodized in the sports drink, I should probably drink it now. Bottoms up. Anodizing didn't change it. All right, good to know. All right, here we have the piece that was done in our sports drink because it's got electrolytes. Also, only getting to bronze. And some, you see in there some strange pitting and discoloration. I think that's probably from all the sugar. Don't know for sure. But yet again, still only in the bronze, not even close to the nice blue that we expect. Let's try the beer now. Let's see how that works. Beer. Let's see. I have no idea what this is gonna do. Never done this before. The carbonation, I have no idea what effect it's gonna have. So let's dive in and see what happens. Ooh, another very violent reaction. Just refoamed the beer. Okay. Where are we at? Well, that's about as good as it's gonna get. This one also not nearly as stinky as the ocean water. Now, you know, for science and to really verify what's occurred in our solution after anodizing. Cheers. Tastes like Coors Light. You can see in the beer, we have a nice bronze color. Again, still not pushing up to blue. You saw it was a very violent reaction, but unlike the sports drink and the seawater, Not getting any weird discoloration or pitting, but still not blue. Let's do some dish soap. Except it's already bubbly, and we can't see if there's any reaction taking place. Something's happening. Oh look, it's kind of bronze looking. Now this is interesting. We have a much more vibrant bronze from the dish soap solution, but still only bronze at 33 volts. Really like to see a blue at 33 volts, but so far everything is bronze. Now, with all pseudo-scientific experiments and demonstrations, we do have to have some sort of control group. Now, we already did the one in the rust remover solution to see how things theoretically should look at 33 volts. Now we're gonna do distilled water, which should have no electrolytes in there. It is just pure H2O. So we should not see any reaction. There should be no no colors on there. So let's dunk it in and see what happens here. Make sure you can see the cathode. Okay, so look, you can see our workpiece, there's no bubbles forming, nothing. Here on our cathode, there's no chemical reaction happening. We see no bubble or anything, which means electrons are not transferring. And distilled water, focus, does nothing. You can see here, the distilled water, no effect. This is raw orange peel titanium. I have no additional oxide, no change of color, nothing. So that is the distilled water. So, you know, the theory holds that water without any electrolyte will not anode, no electrons will move, so we see no effect. Here are all of our pieces. Right, that's our rust remover at 33 volts. Here's distilled water at 33 volts. This is tap water at 33 volts. Ocean water at 33 volts. This one is soapy water at 33 volts. Nice, use this one. That one is our sports drink at 33 volts. And this one is good old Coors Light, some beer at 33 volts. So you can see here that while all of these solutions, except for distilled water, are electrolyte solutions that will conduct electric current, they're not all created equally, where we have a pretty big difference depending on what our solution is. That's why you see a lot of people will use like TSP, rust remover, various things like that. They just are a more efficient electrolyte and allow us to build up a proper oxide layer and get better colors. And I'm going to go ahead and disclaim this and say I do not know exactly what's causing the differences. That is way beyond my understanding of chemistry, and this is a very rare instance where we don't necessarily need to know the why, we just need to know the what and how to control it. So there's a little take on anodizing with different electrolyte solutions and the effects that different ones have.